second, guys. So yesterday we have discussed till the partitioning and budgeting, right? So for the people who got missed, partitioning is like if you are working for a full chip level. Yeah, if you are working for a full chip level, then the chip will be like, I mean, the chip will be like two types, whether it is a flat or hierarchical. Okay. So if it is a flat, no need of partitioning or budgeting or etc. etc. If it is going through this hierarchical way, okay, then the chip will be divided into some of the subsystems, and subsystem will be divided into partitions or blocks. Okay, at a fresher level, you will be working as a block level person. I mean, if your lucky is good, I mean, if you have some luck, then you will be working for full chip level also. But usually for a fresher level, you will be working for a block level only. Okay, for example, if this is a whole chip, okay, then this particular thing will be divided into subsystems. This is like subsystem 1, S2, S3, and S4. Just give me a second. Yeah. So every subsystem will be divided into partitions. Okay. These are like kind of partitions. Okay. Somehow, I just tried to show you different types of partitions. Okay. I mean, this is not like a fixed way. Your partition will be like a rectangle or a rectilinear or some other shapes, or it might be a channel partition or something. Okay. So this is like partitioning. If it is like flat model, no partitioning at all. Okay. If it is like a hierarchical, partition will be there. Okay. So this is how you're going to decide. I mean, a full chip level guy will be divided into a full chip into subsystems, and subsystems will be divided into partitions. Okay. So in the full chip level, these partitions will be clubbed and make one subsystem. Okay. Then they'll club the subsystem and they'll make the full chip. Okay. Now based on that, they are going to see that. I mean, they are going to perform the timing or floor plan or etc. 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 Okay. So the same thing after budgeting. Yeah. This is the thing, budgeting. Budgeting means this particular subsystem is having two VDD ports or two VDD pins, ports only. Okay. Or IO pads. This is having two, this is having two, this is, I mean, wherever you need enough amount of supply or more supply, there you need to give, I mean, you're just trying to give the enough amount of power by including the power as well as signals also, not only the VDD and VSS. We have some signal pads as well. Okay. Some of the signal pads, some of the like some other things. Okay. Pads will be like very different. I mean, for different purpose they will be placing. So what are the thing? So here, for example, some XYZ, this is like some XYZ operation, it is needed, this particular pad. Okay. In this particular area only, the respective macros are there, for example. Okay. At this point of time, here you are placing, means this is how you are going to plan, where we are going to see the real-time requirement. There you need to plan the respective pads and giving the enough amount of power or the signal. I mean, you are making sure that you have nearby source. Okay, that is how you plan your pads and all. Okay, this is what we call as budgeting. Okay, what's this one? Yeah. After that, floor planning, placement. I mean, we already had the discussion about these things, and we're going to see the in detail analysis in the dedicated steps we have in the further classes. Okay, we're going to see in the further stage. Okay, so this is what partitioning and budgeting we never discussed in detail, right? So that's why I thought of telling you people again. So this is the thing in the ASIC flow. So next, let's see the thing. What are the inputs for physical design? Okay, so let's see what are all the really required inputs for the physical design and how we're going to get the thing. Let's see the thing. See, gate level netlist. From which stage we are going to get the gate level netlist, Pandey?
Synthesis.
Cool. So synthesis, what we are going to perform in the synthesis? I mean, just one word answer.
Converting the .p files to .vg files.
Oh, you renamed you. I mean, you changed your name into Pandey.
Sorry.
Nagendra?
Sorry,
Cool.
sir.
Cool. So we're just converting RTL code into gate level netlist. We're going to get million kind of very more number of .v files. Okay, we're going to collaborate all those things and we're going to make a gate level netlist. Okay, so this is the one of the input. Constraints means .sdc. Okay, full chip level people will be giving some constraints. Okay, see, we already discussed the thing. So for example, if clock source is here and if it is getting if it is communicating with this particular partition through this particular port, okay, at this point of time, what is the maximum input delay for this particular thing? There we are going to get through the SDC file. Okay, so this is how every constraint you can see. Creating a particular clock means I'm not telling through the SDC you are creating the clock. Your clock is already created. So you are telling the tool, I'm creating the clock from this particular clock source, and it is going through this particular port and all. Okay, you're just telling the tool, okay, this is how I'm going. Okay, then the tool will be calculating in the respective manner. Okay, so create clock, create generated clock. I already told what is the difference between create clock and create generated clock, right? So anybody have doubt between create clock and create generated clock and create virtual clock? Anybody?
No, sir.
Cool. So the create clock, create generated clock, create virtual clock, and what are the set max, set input delay, set output delay. All these are like constraints, and we have some exceptions like half cycle path, multi-cycle path, etc., etc. These are like timing exceptions. Okay, everything will be there in the constraints. I think we have the detailed explanation of this particular thing. Yeah, we have the detailed explanation. Fine, let's see the thing. So logical and physical libraries. Okay, so these are kind of libraries where we are going to get the I mean we're going to grab the real thing. Means if you are estimate, I mean if you are assuming one particular AND gate, okay, then you are going to get the AND gate from this particular logic library, okay, or this physical library. Okay, this def is like design exchange format. Okay, so this is like, for example, if you are working for a let me show that. If you are working for this particular partition, for example, okay, if you are working for this particular partition, okay, now you need to get the real-time placement of particular macros because this is a hierarchical model. You will be getting some particular def file from the subsystem level people or from the full chip level people. Somewhere you're going to get that def. Okay, in some cases only you're going to get the def. Okay, so this is the def you're going to use as the input. For example, you got some def, that is fine. So you performed your floor plan. Okay, so now you're going to get one particular output, right? Just give me a second, guys. I got to tell you one thing. So, yeah, what would, yeah, fine. So the floor plan, if you, for example, you perform your floor plan, okay. So now you need to tell like, I have some floor plan output, right? So what is the format of this particular output? Is called .def, okay. Whatever the stage you performed in the PD flow, okay, the output is like .def stage, okay. So usually we call it like just give me the DB, means database. We usually in a normal using word, but the format is like .def file, okay. You'll be getting the placement def or floor plan def, means the output stage, the output format is like .def file, means this will be having the information of this particular entire stage information. If you perform your floor plan, your output will be like floor plan .def, okay. So if you source this particular def, this is enough to show you the physical context of every cell. You don't have logical context. If you need logical context as well, you need to have the logical libraries, okay. So you have the physical floor plan.def only. So you can see in your particular block where your macros are there, where your cells, okay, for example, for the floor plan you don't have cells, right? So where your macros are there, if you have any cells you have placed in the floor plan itself, what are those and where they got placed? Okay, these are like some kind of ECOs or some, because of some of the pre-routes, okay, some of the pre-routes, all these things. What all you have performed with respect to the floor plan, everything will be there in the floor plan.def, okay. So this is the def output, okay. This is the def. Scan def is like how to tell, fine. So as I said, right, you're going to do some scan chain concept, then you will come to know the how much the length these cells got spreaded over the chip or over your partition, okay. How much time it will be taking to perform all these things. DFT people will be doing the scan chain method, okay. They're going to test the thing, okay. DFT stands for only design for testability, right? So they're going to test the thing and they're going with the help of this scan chain concept, okay. That particular scan output we're going to get, which is called scan def, okay. UPF is like this is like very important thing, and if we get enough time we will discuss about this UPF also. UPF is like, for example, this is your partition. For example, this is your partition. I'm not talking about the full chip. This is your partition. Okay. This is how your what is it called, voltage areas will be looking like. I'm just drawing a voltage areas. Okay, these are not macros I'm trying to draw. Voltage areas means this particular area, what are all the cells inside this particular area will be working for some different voltage. For example, entire chip is working for some 0.8 volts, but this particular voltage area is only, I mean, these particular cells will be working for 0.6 volts only. This is different to voltage area. So this is like 0.7. This is like 0.9. This is like 1. For example, I'm just giving an example. The remaining all the cells, all of the cell, all of the chip, or all of the your block, your cells will be spreaded over, right? So the remaining cells will be working for 0.8. This particular area, okay, in this area, the cells will be working for 1 volt, for example, in this area, 0.9, etc., etc. Okay. So these are like separate voltage areas. Okay, means this particular area of cells will be working for different voltage. Okay. So this is like these are like voltage areas. Okay. So these voltage areas, yeah, the information related to this particular voltage areas you can see in the UPF. Okay. CPF is the one of the format. Okay, this is like a very old one. Okay, this is the latest. I mean, if you are working for the lower power technology or multiple voltage areas, if you are having, then you are going to see the UPF, UPF file, and CPF is a low older version. What is this UPF stands for? So what are the cells in the respective voltage area? What are the cells? What are the combination of cells you are seeing? What is the voltage of this particular voltage area? Okay. So which is the majority of power supply, which is the minor, I mean, which is the positive supply, which is the ground supply for this particular voltage area, which is the positive supply, which is the ground supply for this particular voltage area. Okay, this is how information will be looking like in the UPF. Okay, UPF stands for
Unified power format.
cool. Unified power format. Okay, this is a separate thing. Tell me the person who told this UPF. Tell me the CPF.
Sir, I don't know because I seen UPF during like Udemy course.
Acha, acha. Cool. Fine. CPF is like common power format. Means if you don't have any voltage areas, every entire chip is working for a single voltage, then CPF, common power format. This is like very old version. Just for knowledge sharing, I'm just trying to tell this thing. Okay. UPF is the advanced and trending thing, which is called unified. Let me write for you. Unified power format. Okay, this is the UPF, and this contains the information of this particular voltage areas and with which voltage each voltage area is working on, and what are the combination of what are the family of cells will be living in this particular voltage area, what are the VDD power for that particular thing and VSS power for that particular thing. Means what I'm trying to tell is like, 1 second, let me tell you. See. For example, in my previous project, I have 7 voltage areas. Okay, so for first voltage area, VDD power source is like VDD core underscore SW. Second thing is like VDD IO. VDD core RAM. I mean, in this manner, okay. VDD supply will be like same. Sorry. VDD supply will be like differentiated. Okay, because of the different types of voltages. Okay, so VSSIO the same thing. If the ground power is like same, I think so. VSS is like same for everything, for every voltage area. Yeah, I think so. In some scenarios, some special scenarios, VSSIO is like different, but most of the things VSSIO is like common for everything. Okay, so here for one particular voltage area, VDD power means VDD IO is converted into VDD core SW. Means usually VDD, for example, if this is like 1 volt. Okay, for one respective voltage area, this is like 0.9 volts. Means we reduced the voltage and we named it into VDD core SW. Okay, the same thing. And some of the cells having VDD IO only. So 1 volt. VDD core RAM, this is having 0.6 volts. So we converted this 1 volt into 0.6 volts and we renamed the particular voltage VDD power into VDD core underscore RAM. Okay, in this manner. Okay, so this is how your every voltage area power, I mean primary and ground power will be renamed. I mean, ground is like same, but the VDD power is like will be differentiated. Okay, with respect to the voltage. Okay. So this is what UPF will be giving the information. Okay, let's see the thing in detail. So gate level netlist. We already discussed multiple times. So what is the gate level netlist and everything. Okay, let me tell you one more time for the thing. Common to design components common to beautiful sensor. Okay, fine. There is a thing. So it contains only gates and logical connections to other gates. These logical connections make our intended logic. Okay, means what I'm trying to tell is like, for example, if you have one particular AND gate, okay, so this is connected to one OR gate, for example. Sorry, this is a inverter. Fine, this is connected to some particular inverter. Okay, this is called one AND gate and X1. This is one NOT or INV X2. This is the logical connection. Okay, what is the net name between these two? This is the information. Only this information will be available. Okay, any logic thing. Okay, and the connection between any two logic cells. Okay, only this information will be available in the gate level netlist. The name itself is telling gates means logic gates, right? So contains only gates and logical connection to the other gates. That's it. These logical connections make our intended logic. Means, I mean, just forget this statement. So the thing is like, obviously, and I mean, in a simple manner, what are the gates you have? What is the net name between any two gates? That's the thing. Only logical connectivity, okay, will be present in the gate level netlist or netlist. Okay, netlist format would be Nagendra. Netlist format. Nagendra, are you there?
Yes, sir.
Yeah, netlist format would be, I mean, the format, how we use, we recognize this is the netlist. What is the format, output format?
.vg files.
What if that is a .v?
.v Verilog codes.
Yeah, that's it. So this is how you can differentiate. VG, gate level Verilog code, means gate level netlist. You can just try to remember the thing. Okay, so that's it. So design compiler is a common tool for synthesis. Usually Synopsys tool, I mean, from Synopsys DC compiler or design compiler is the tool to perform the synthesis. Okay, from Cadence, I really don't know. I never worked for Cadence much. So from synthesis, design compiler or DC compiler. Okay, so is a tool to perform the synthesis. Nowadays, so we are using Fusion compiler. Okay, Fusion compiler is like, it is performing the design compiler and ICC and DC compiler and ICC compiler operations as well. Okay, in the single tool. Okay, so Fusion compiler is the latest trend from the Synopsys. Okay, usually
Sir.
design compiler is the dedicated tool for the synthesis. Yeah, Nagendra, tell me.
Our design compiler is introduced by the Synopsys, right? Synopsys.
Yeah, true.
Oh.
Fine. So that is the thing about gate level netlist. We don't have anything inside the gate level netlist. Simply logic gates and the connection between these two. What is the net name between those two? And what are the gates? How they got connected? That's it. A very simple thing. Okay. So constraints. We already talked about, had conversation about these constraints, right? So clock definitions means create clock, create generated clock, and what is the input delay, what is the output delay, what is the IO delay, the same thing. So exceptions are like multi-cycle path, false path, disable timing arcs, and the case analysis. This is like separate different case and some ocean it is case analysis. For example, as of now, just keep the thing aside. So what is the max delay? What is the min delay? All these are like exceptions. Okay, these are the things you're going to see in the constraints. Means, what is the constraint file format, Pandey?
.sdc.
Cool.
.sdc.
Cool, that's it. SDC stands for Pandey, not you. Pandey, not you.
Okay.
Satish. SDC stands for
Standard design constraint or Synopsys design constraint.
cool. That's it. So that's the thing. Kushagra or Krizil, you are aware of these things, man. I mean, what is the extension of this .sdc, .vg? These are the formats of netlist and SDC files.
Sir,
You're okay, right?
.vg, .vs, I know, sir. Because,
Okay.
like, sir, I have to ask one thing that I have done one type of net listing, but it is like CMOS net listing. Like I have,
CMOS netlist.
yes, sir. I have done like I have opened a notepad and just give a name, and in that I just write the each CMOS name like VDD, ground, source. Then approx that after that I compile whole the thing in Xilinx IAC tool. It make the whole graph like it is a AND gate, OR gate, or what is it is Boolean formation. So this type of net listing is different from gate net listing, or it's both the same thing?
Gate level netlist or netlist, both are same. There's no difference. But the thing which you have seen might be with respect to the design verification people, with respect to DV people. I think so. I really don't know what you're talking about, but the thing is like netlist or gate level netlist, both are the same only. Okay, no issue. Yeah. So these are the things we see in the HDC file and constraints. I mean, constraints we used to call. Okay. So let's see the thing. Physical library means one of the format is like left, .left. Okay. dot left, library exchange format. Same thing, right? Yeah. So library exchange format means, see, everything, I mean, every time you just remember one thing. Okay, only one thing. The difference between what are the physical and what are the logical libraries. Okay. Dot lib versus dot left. Okay. Dot lib gives the most related information with respect to the timing of a particular cell, power related issue, power related values. Okay, I mean, these are like technical things, the logical things. Okay, left is like physical things. What is the height? What is the width? What is the shape of a particular pin? Okay, the physical aspect you are going to see in the dot left format. The technical or the logical information you can see in the dot lib format. Okay, so this is the thing. So yeah, I can tell.
So can we consider it as a dot library files will give the specification of an any standard cell,
Yeah, that's it.
and dot lef, I mean left, which will
Hmm.
give the physical structure of the any
That's it.
standard cell.
That's it.
Okay, sir.
See, we have some tran values and all, right? So if you are getting some tran violation, okay, when you compare with the some standard level, if it is less, I mean, if it is under control, you are in positive side. If it is exceeding the tran time, it is you are getting the violation, right? So you get the particular reference in the this dot lib file only. Got the thing? What I'm trying to tell? See, what I'm trying to tell is like, for example, and this is one of the flop and this is the one of the flop. Okay, this is the logic, some AND gate, some etc etc. So one buffer, one inverter. Okay, this is how your logic was there. Okay, combinational logic. For example, now you got some setup violation. Now you see the thing. So because of the AND gate, this is, for example, it is taking 1 second. This is taking 1 second. This is taking, inverter is taking 1 second. For example, this is like, AND gate is like taking 2 seconds for just for example. Okay, so now you see the thing. Okay, now you are getting some tran violation. For example, now you are getting some tran violation here. Okay, why you are getting tran violation? Because of this is taking more time when compared to the required, when compared to the ideal time, it is taking more time. Why? Because this is being driven by a small sized buffer. Okay, somehow it is managed to drive this thing, but it is not able to, the signal is not able to move from the AND gate output. Okay, why? Because this should take only 1 second, but this is taking 2 seconds. Why you got this reference? How you got this reference? In the dot lib file, you will be getting this information. This particular AND gate will be taking only 1 second to give the respective output, but this is taking 2 seconds. Means that's why you are getting some tran violation here. Just to compare. Okay, if you have some reference, then only you can tell whether it is violating or not violating, right? So dot lib file is the reference. Dot lib file will be having the required information with respect to the timing and power related thing. Okay, got the thing, Nagendra? What I'm trying to tell. Nagendra, are you there?
Yeah, sir.
Cool.
Got it, sir.
So that's the thing. So now we are talking about the physical library. So let's talk about the left. See, what is the height, what is the width, what is the pin shape, etc etc. Just forget all these things. Any physical aspect of a particular cell, blindly go and check dot left file, left library exchange format. This is the thing. See, the left file is the abstract view of cells. It only gives the idea about PR boundary, pin position, and metal layer information of a cell. Left is like used in conjunction with def to get the complete layout view. Fine. See, this is how, I mean, a physical information about a particular cell. That's it. Okay. So let's see the thing. Same net spacing, site, must join pin, macro abstraction sheet. What are all these things? Fine. Let's see the thing. Let's see what are the things it will be having. Same net spacing. Let Okay, this is shown in the same. It is defined in the same net spacing is less than different net spacing. Site row, multi-joint pin, macro obstruction statement. I don't think. Oh, fine. Fine. See, for example, dot left is the one of the left file. Sorry. Dot left is the one of the physical library. Okay. In the same manner, what other physical libraries will be containing? Okay. Some of the physical see. For example, only we take the dot left, dot technology file, etc. These kind of files. Okay. We get millions of libraries. Okay. Some of the library will be containing some of the information. Okay. So one of the library which is having some same net spacing. For example, this is the thing I tried to tell you with respect to DRC. I think I tried to tell, I told you this thing. So for example, if you have a M5 metal layer, and if you have one more M5 metal layer, these two are like M5, right? So what should be the space between two same metal layers? Okay, these things will be mentioned in this physical libraries only. Okay, see, the thing is like metal layer means physical thing, right? So logical means we are talking about the timing or something. Physical means metal layers or its characteristics or a particular technology, everything. Okay, so height or width or something. Okay, so same net spacing. This rule determines the minimum spacing between geometries in the same net. It is only defined in the if the same net spacing is less than the different net spacing. Okay, fine. For example, these are like very in a definition ways. I'm just trying to simplify these things. Okay, so if you are having two same metal layers, the distance between these two things will be defined through this physical libraries only. Okay, site row, site specifies the region of a block like pad and core. Under this syntax, symmetry is also defined as with respect to x and y are R90, rotate by 90. Fine. See, the thing is like, for example, if you have pads like this, so from which area means, see, whenever, just remember this thing, whenever you're talking about a particular thing, whatever the thing it is, whether it is a macro, whether it is a standard cell, whether it is a pad, whether it is the entire chip, you need to talk with respect to the coordinates, XY coordinates. Okay, some 25.3 to 36.64. Sorry, 46, whatever. Okay, this is how your coordinates will be looking like. Means 25, 36. Here, your one of the cell. See, if your cell is like this, you're going to get 4 coordinates. Okay, some, for example, some 1, 2, 3, 4. For example, I'm just giving same in this manner. For example, 1.1, 2.1, 3.1, and 4.1. Okay, these are the 4 coordinates. Okay, so 1.1 is like this particular thing. Okay, so 2.1 is like this particular thing. From here to here, one cell is there, and 3.1 this particular thing, and 4.1 this particular thing. This is the, so in this area you have a one particular cell. Okay, whatever the thing you talk about, this is how. Okay, usually in our industry, in the daily life base, we take only these two, because if you take this particular thing and this particular thing, you get the you are getting the coordinates, right? You will be getting the cell, no need of using this particular thing. But this is like a perfect shape, means this particular 4 coordinate. If you take these two, means the first 2 things, you can get the this particular coordinate, this particular coordinate. These 2 coordinates. This is also fine. Okay, so in the daily life basis, this is not like a definition way or some mentioned way in the textbook or kind of stuff. Okay, this is like a daily life basis. Okay, so wherever the pads you have, from which coordinate to which coordinate, what is the height of this particular pad, what is the width of this particular pad, everything will be like defined through this physical libraries only. So must join pin, this specifies the name of the pins to be connected together. We have some special conditions where these 2 pins should be connected. Okay, So that particular must join pin is like, that is like a separate concept. I will tell in the, I think so in the route or fine. I think so in the route only, this concept will come into the picture. Okay. So some of the pins we should connect. Means when we are connecting, we are using the route only, right? We don't have any other choice. Route means a wire, electric wire, right? I mean, electric wire we use in the regular daily life basis, but route with respect to the PD terminology. Okay. So must join pins we have. So what are the pins and what are the things you should connect? Definitely. I mean, these are like some separate cases, some special cases. Okay. So macro abstraction statement means the OBS file defines the group of abstraction on macros. Normally this blocks the routing, but in case of abstraction on pin, it allows the routing. The thing is like abstraction. The name itself is telling means some blockage, some restriction, some guideline. Means usually on any macro, okay, by default routing blockage will be applied. Okay, no routing metal layer is really allowed on the top of the macro. But for example, in my previous project, I have one RAM like this. Okay, so why we are not able, why we are not allowed to route any metal layers? Why? Because inside this macro, the pins were like this. These are like some 3 to 5 pins. Okay, P1, P2, P3, P4, and P5. Okay, so pins were like this, and these pins were routed on M5 metal layer. Okay, all these are like M5. So if we allow the tool to route over this macro, okay, then this M5 will be shorted, right? See, whenever or wherever, okay, if same metal layer but different layer name, sorry, a different net name, okay, same metal layer means 2 M5 metal layers, okay, but one metal layer is like from metal A and net A, and second layer is like some net B. 2 same metal layers, 2 M5 metal layers only, but belongs to different nets. Okay, for example, this is a clock. Here it is coming. This particular net name will be like clock A, for example. Here you have some, you have generated one more clock. Okay, this is like M5 only, this particular metal layer. This is like M5 only. Somehow it came like this and this got short. This is a short. Why? Because this is like clock gen underscore A. Means this net name is like clock gen underscore A. This is a different family. Clock is like, don't include the clock thing here. I'm talking about the particularly metal layers. Okay, so this is the M5 metal layer, this is the M5 metal layer, but this particular net name is a clock gen underscore A. This particular net name is a clock underscore A. So 2 different net names, same metal layer. Okay, then this is the short. Okay, why you are talking about? Yeah, so that is why if we have a pin with some metal layers routed, okay, this particular macro, inside the macro, what are the routing, what are the metal layer routing, you really don't care, because this is the headache of analog layout or analog circuit people. Okay, inside macro, what are the metal layers and how they got routed is like not your problem. Okay, only all over the partition routing is like your problem. Okay, that is the thing. So inside the macro routing, it's like analog layout people will be doing all this stuff. Okay, so for example, if you allow to travel the metal, I mean if you allow the metal layers over this macro, this will be shorted, right? For example, this is like some of the pin, some of the metal layer is going on like this. Okay, some VDD/IO is going on like this, but this pin is like VSS/IO. This is like short circuit, right? So that is why by default we will be seeing some blockages over the particular macro. Okay, so we have till M5 we have the blockage for this macro. Okay, so beyond M5, M6 or M7, if you have metal layers, you can go through, because you don't have any M6 metal layer here, right? So that is the same thing explained here. See, the OBS defines the group of abstraction on macros. Normally this blocks the routing, means the abstraction blocks the routing, but in case of abstraction on pin, it allows the routing. Okay, the thing is like, for example, if the pin is like M5 only, okay, till M5 we have routing blockage, so it won't be taking any M5 on this macro. But M6 and M7, you don't have any pins, so it will be, it can allow, no short is there, right? Nothing it is harming for you, right? So that is the thing. So all this information you can get through the physical libraries only. Okay. See, logical libraries means timing related information or logic information. Physical means everything, height or width or area or space where it got placed, and with respect to the metal layers, the distance between metal layers. Okay. The space should be there within metal layers, the maximum width of metal layers, everything will be comes under physical libraries. Okay. Means we are seeing the thing. Logical things we are not going to see, right? So how AND gate operates? If you give two inputs one, you will get the output one. How it will be working? You can't see the thing, right? It is like internal operation. This is like logical. Okay, physical is like two inputs are there. We can see the two inputs. We can see the one output. This is like physical. Okay, this particular, I mean, all this information will be present in the physical libraries. Okay. So I think we already crossed the time. So that's all from my side, guys, for today. So let's see some more things for tomorrow. Okay. So what is the MWLib dot lib liberty file, voltage current unit? Fine. Fine. We have lots of things more. So let's discuss about all these things tomorrow. Okay. So that's all from my side, guys. So if you have any queries regarding this, please let me know. If you don't have any doubts, please move on. Nagendra, tell me. Nagendra live. So Satish, Pandey, Krizil, any doubts?
No, sir.
Cool. I mean, everything fine, right? Satish?
Yes, sir. Fine, sir.
Cool. So anybody else? Anything? Cool. So that's all from my side, guys. So if you have any queries, I mean, we already only 3 people. Fine. Let's wind up the session for today and see you guys tomorrow. Okay.
So tomorrow we have
Because-
class, sir?
Yeah, obviously. Don't you want?
Okay, no, sir. Vinayak Chavithi. That's why I asked.
I know Vinayak Chavithi, but
Just formally ask, sir.
yeah, I mean, if you people are requesting, I mean, if you people don't want the class, we will postpone the thing.
No, sir. Only morning we do.
Sorry.
Only morning we will celebrate it, sir.
Yeah, that too, just for 1 hour, right?
Yes, sir.
We should not postpone the things. These are like a serious things, right?
Yes, sir. Yes, sir. We
Because of
have-
the festival or something, we should not postpone the thing. If it is like a really serious thing, we can. But obviously, for a festival thing, we should not skip at least for 1 hour of class, right?
Yes.
So there would be a class, no change. And if any management talks like, I mean, if management asks like, don't put the class and all, then only we will intimate through the group. If not, join as usual.
Okay.
Cool. Thanks, man. Bye. Good night.
Thank you, sir.
Yeah. Bye.